Thank you. Okay, so my name is Paul Hudson, and I'm talking to you about debugging. You may know me from a website I run called Hacking with Swift at hackingwithswift.com, great website. I also run free online courses such as the new one, Swift in 60 Seconds, which teaches you all these Swift fundamentals in a minute or less. Plus these Swift Community Awards where you can vote for your favorite people and projects. My main job, my actual job, is writing books about Swift. Hacking with Swift, hacking with macOS, tvOS, Pro Swift, Swift design patterns, server-side Swift, all sorts of things about Swift. And in fact, if you go to this URL, you too can have a free book just on me, gum.co/swiftcc/appdevcon. It's Swift Coding Challenges. It's valid for about 4 hours from now. Don't hang around. Go ahead and get it now if you want. 10, 9, 8, 7, 6, 5, 4, 3, too slow. If you want to get in touch, if you have questions after, by all means, get in touch, talk to me. I am at 2straws on Twitter. I am 2straws on GitHub. I am 2straws on Reddit and 2straws on Stack Overflow. Once you remember the first part, I'm pretty easy to find. Or if you have questions afterwards, email me. I am Paul at hackingwithswift.com. So my talk is on debugging, aka the process of removing things we put there in the first place. All the mistakes we actually are responsible for and usually blame the computer for. Now when I say I'm talking about debugging, I often get two responses. Firstly, God, a debugging talk. It's my chance to catch up on some sleep, quite frankly. People zone out. If that's you, please try and perk up. I'm going to try and cover as much ground as I can today. And of course, this is just the first talk in a long day. Secondly, some folks who consider themselves senior developers will say, I already know everything about debugging, so I'm just basically here to talk on Slack. If that's you, Ellen Shapiro is giving you a great talk just over there, learning a new language while learning a language. Go to her talk, I'm sure it's brilliant. Today's plan. Firstly, the absolute basics and reading values in the debugger. Then breakpoints and watchpoints, debugging layouts, and finally, just briefly, debugging memory problems. Now, spoiler alert, there is no magic involved in this presentation. I did a whole day talk yesterday on advanced Swift, and someone asked me, when's the magic coming? And the answer is, there's no magic. I don't like magic code. I try and make things as simple and approachable as possible. And a simple truth is that people who debug excellently are just folks who know their tools. The same tools we all have, the same basic tools we all have, using them wisely for the right thing. You will notice there is no instruments in my talk. That's a whole other talk. And there's no testing in my talk. Again, different talk. I'm going to assume you totally already write great tests. Yes? Yes. Amazing tests. 100% coverage. Good. So, the basics. Good old print. Now, you use a print, type it in, and it kind of works well. But what normally happens is, it didn't quite hit the spot. So you add another print, and then another print, and then some more prints, and then print, 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 print. And eventually, you find the bug you were looking for. It gets kind of messy. And the simple truth is that half of folks use print some of the time, and the other half use print all of the time. And you know what? I'm cool with this. This makes absolute sense to me because almost certainly the first thing you learned while you were programming. Programming 101. This isn't working. Print, why not? And you learn that and it's baked deep into your psyche. And to be fair, it's also often the easiest approach. A simple thing you can reach for and solve things quickly. What we're doing when we say print is flattering ourselves. We're basically assuming we understand the program flow fully, and we just try to see out where it got tripped up somewhere along the way. So we're flattering ourselves. And to be fair, using print actually is fine a lot of the time, because it will solve the problem in half a second, versus reaching for a whole more complex tool, setting it up and so forth. That takes time to do. Whereas print, you can be done very, very quickly. So, when you use print in your debugging, you have my permission to relax and feel good about yourself. Everyone does it. You're not alone. In fact, I even made an Xcode source editor extension just for you. It's called Sharpshooter. It's on GitHub. It's open source. And it's named after the Texas sharpshooter fallacy. It's about a chap who comes to a sort of Wild West town and says, I'm an amazing shot. And to prove it, he takes his gun and shoots at a barn wall. Bang, 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 bang. Then draws a big circle around the number of closest hits together and says, look, that's how good I am. And what it does is Sharpshooter takes code like this, generic class full of method, 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 and when you run it, it will add entry points, comments, to every method. So you can see what your code's doing, and then with another click, boom, they're gone. If you like print, it's for you. But when you add print to your code, what you're really saying is, this is a milestone in my code. I want to check my data here is what I think it is. So you're adding milestones in your code with print. But the problem is, print makes you check those milestones yourself. You've got to read the output and say, yes, that is what I thought it would be. That is what I expected. My program is in a good state. And of course, Swift has a better solution, the assert function. You can assert whatever you like. Assert this function here, some code returns true. Xcode will run that for you when your app runs. If the condition fails, your app will crash, which might sound silly at first. Who wants their app to crash? But the source code for assert, which we looked at yesterday in my Advanced Swift workshop, looks like this. It's got this lovely call at the top saying, if is debug assert configuration, meaning that if I'm in debug mode only, if my app is running from Xcode, which means when you ship to the App Store, on real apps, on your iPhones and iPads, the debug assert stuff gets compiled and piled out entirely. It goes away. So you can assert whatever you want. Are there 5 users in the array? Does this slow code return true? And it doesn't matter that it's slow. It might take, a tenth or a half a second to run, but real users will not see that. It's just for testing purposes. So I encourage folks to get into the habit of sprinkling assert calls everywhere in your code. At the start of each method, assert your state is what you expect it to be, what it must be for that to continue. And again, all those calls go away in App Store builds. They have zero performance impact on your code. So, if you do nothing else after this talk, on Monday, back to your desks, count how many assert calls you have, then double the figure. If you have 0 assert calls, come and see me after class. I've got a special message just for you. They help you spot bugs faster while you're developing. They point out when your program state is not what you thought it was. Please use assert. If you think, I really don't need assert here, I'm totally sure it's safe, that's where you will find a bug that assert will catch for you. Swift has an alternative called precondition. Works very similarly. You can do precondition some code. If that returns false, your app will crash if that is not true. However, precondition will not be compiled out when you ship for release. And yes, that means your app will crash for end users too. That's the point. It means your code is not safe to continue. This big number here, 246, that is how many times the Swift standard library uses preconditions. So you are already using preconditions, just not necessarily directly. If you say, remove last on an empty array, that will crash your code at runtime for users. It's a precondition. If you try and make a reversed range, 10 down to 1, precondition, that's not allowed. Dividing by 0, precondition, it will crash your code. Even out of array ranges is done using preconditions in the standard library. They use them everywhere, so why don't we? Third option, fatal error. This will, unsurprisingly, crash your code. Getting a theme here. This is unconditional crash, even for users. There's no test involved. This will just crash your code. And this is really useful. Here is a function definition from the Swift standard library. And the main thing you want to look at here is the return type, never. The Swift compiler understands that to mean this function will never return. Your app will go away. Don't worry what happens here. And so it's brilliant for catching actual logic errors, mistakes you have made in your code. So dequeuing cells from the storyboard with identifier that don't exist, or loading view controllers from storyboards, or trying to read the app bundle like UI image named. Either the image is there, or you've made a mistake. Either the view controller is there, or you've made a mistake. Table view cells there. You cannot recover from those meaningfully at runtime. And if you try and do so, it will just mask the problem. In fact, if you listen to the Swift Talk show, they had an episode recently, and this chap here said, great episode, really like how self-contained it is. Consider replacing return result value.map $0 force unwrap with return result.value.flatmap $0. Chris Eidoff responded, it's very much on purpose. It's like that by design. The values cannot be nil. It would be an implementation error, a logic error on your behalf. Using flatmap silently emits the value, you'll get a crash in a completely unrelated spot. So when you hear folks who say, oh, we never force unwrap, they're just wrong. And they should be told how wrong they are on a regular basis. If something is fundamentally wrong with your program, if you cannot read your app bundle, or if you're missing a storyboard identifier, crashing is better than continuing. You've made a fundamental mistake. Potentially, user data might be corrupted if you continue because the app's really broken. Would you really rather carry on limping along with guard, or just crash and let them relaunch and recover from there? So, use assertions everywhere. Use preconditions where it really matters. And fatal error sparingly. All three are important. All three should be in your code. Because when they combine, they effectively automate a large part of your debugging. You know for sure your code is in the exact state you wanted. So when you hit a problem, you've already got a great foundation to work from. You know all these things are true, so it can't be those things, it's something else. Just this week, Peter Steinberger, speaking at TechieCon, said this, best debugging is no debugging. Also rephrased as, you don't need to debug if you don't write any code. So, let's look at reading values. You should all be familiar with this lovely little prompt in the bottom right corner of the Xcode window, the low-level debugger. It wants to have a conversation with us. Great. There's some lovely commands you can all use. You should know that P prints primitive types. This integer, so it'll say, here you go, its value is 10. Or there's PO, printing objects. This is an object, it'll say, here's its memory address. Now, if it has a debug description property, that'll be used. If it has a description property, that'll be used. This thing has neither, you just get memory address. But LLDB can be cleverer than that. If you said instead, rather than just PO this object, if I had said P that object, just figure out LLDB, then it will display all the properties of it. So you can work your way through and see exactly what its state was at runtime. But whether you use P or PO, they both carry some element of risk, because you're actually compiling and running code inside your app's process. You can mutate values. It's the observer effect. By calling a method, you might change the state of your program. So you should use frame variable for times you really don't want to change anything. FRV, or frame variable, will show you the value of a local variable without changing anything. So here, I can say FRV username, and it'll say username is equal to 2 straws. It will not run methods or getters and setters and so forth. It'll tell you the value directly. It will not ever trigger changes. On the flip side, EXPR is when you want to make changes. I want to inject this value into my program right now. And this really baffles some people. Why would I want to put code in there at debug time? Well, this is here, Xcode being paused. You'll see that sort of vomit green thing on the right-hand side, thread 10 breakpoint. It's broken at that line. Those 3 little lines are a drag handle. You can grab those things. It's the instruction pointer, and then move it somewhere else. You can say, start running my code from here. And Xcode, of course, will warn you about this. It'll say, are you quite sure you want to do that? There might be unintended consequences here, like over-releasing objects, for example. That's fine. Go for it. Now, obviously, you've got to know what you're doing. What it means is you combine that with EXPR, you get a debugging superpower. You can work through your code as far as you want, hit a problem. I didn't get that right, didn't understand that. Rewind, reset the variable, clear it back. Nope, didn't get that. change it again, rewind, play it back from the same point every time, rather than to step through the whole thing from scratch. Now, before I move on, I want to say that PO is really useful for times you want to implement your own debug description. It's really simple. Just add this override variable, debug description, to your class or your struct. It's really great for complex controllers that you want to summarize easily. I've used this previously in games, for example. If I was designing some AI, I could say, show me an ASCII map of what you think your next moves are going to be. For a more visual experience, provide a custom quick look debug object. This returns optional any. You can return anything at all, images or text or whatever represents your data. And Xcode's got stacks of these things built in. Just find the variable you like, press this little button down the corner, the quick look button. Here it is previewing a color. Here it is previewing an attributed string with formatting. Here it is doing a Bezier path, many more. Xcode 9 just added CI image from core image. There's PDF document from PDF kit. They add more every year. It's very, very flexible. Okay, that completes the absolute basics and reading values. Let's look at breakpoints. These are those little blue arrows. In their simplest form, instruct Xcode to pause execution of your app at a certain point so you can see what's going on. The problem is, when I work with folks, doing pair programming or mentoring, I'll see them adding breakpoints and removing them again, and adding somewhere else, and removing those, and adding them in the first place again, and removing those. They add and remove things a lot, which is wasting time. Better idea is to double-click, of course, and use conditional breakpoints. Because here, you can have the breakpoint be skipped several times, like let this thing go past 10 times before finally breaking, or have the breakpoint be triggered, but not pause your program. Best of all, you can add actions. So I'm saying here to print the username. Now, this uses the same command, p username, you could do in the LLDB, or in even a print function. It's exactly the same. You had print in your code and p here. The output's more or less the same. Difference is, this command's being injected by the debugger. So if you finally ship your code, and there's print still in there, that's different to it being injected by the debugger. These go away when you ship to the App Store. Breakpoints can also have conditions attached, which is where they become extremely powerful, potentially more powerful than you can ever imagine. For example, you might break when a variable gets set to a specific value. So here it's going to be loop indexes 5. Pause only then. Now this is a feature most people understand conceptually, but don't put into practice effectively. See, it's easy to waste time adding and removing breakpoints and so on, but there really is no need. That's exactly what conditional breakpoints are there to solve. So go ahead and define an enum that lists all the important parts of your project, all the important flows of your program, each with values set to 0. Then add conditions about that. Breakpointmanager.userLogin is equal to 1. So it'll trigger only when you want to debug user login problems. And now leave all your breakpoints in place forever. Don't take them away again. None of them will be triggered anymore because it's all zeros in your enum. And when you want to debug something, make it 1. All its breakpoints spring to life straight away. No more need to keep adding and removing things. Even better, as a little breakpoint navigator, you can filter by your conditions. So here I type user login, it'll find all the user login flow breakpoints immediately. These breakpoints also give you the chance to run external code when breakpoints are hit. This uses the say command on your Mac. It will literally speak back to you while it's working. So when a breakpoint's reached, it will say loading, and then I've checked the mock saying automatically continue after evaluating actions. So it's good for things you can't see, like networking actions. In fact, I learned this technique from Marcos Karatzis, I apologize for the name, at NS Conference 2014. He gave a whole talk about doing sound debugging. And he uses different built-in macOS sounds to represent different program states. That a request start, succeed, fail, timeout, and so forth. And he plays a slide back, and you hear it going bing, click, wong, whatever. And you know, oh, that's this. It started, it succeeded, it started, it failed. So all those things you cannot see are suddenly perfectly debuggable. There are some special breakpoints I hope you're using already, but we'll find out. You probably want to enable these all the time. They are down with this plus button in the breakpoint navigator. The most important by far, of course, is the exception breakpoint. This is really, really important because the default behavior of Xcode is stupid. when something goes wrong, it throws you into the middle of nowhere and says your app crashed, and you're in app.delegate.swift. You're not sure what happened. So this kind of thing in Swift, as question mark detailed view controller, this is a soft fail. Swift will try to typecast a thing, return nil if it failed. But this, dequeuing a storyboard with a bad identifier, this is a hard fail. Your app will crash if this does not exist. This is a logic error. Apple will happily crash your app for mistakes. Like I said, it's a good idea. And of course, seasoned Xcode folks will look at the log and say, okay, we're here. What we really care about isn't that. It's way up there. And they'll find that tiny slice of data. Hooray, the error is clear. But the error breakpoint will help you with this, or the exception breakpoint, sorry, will help you with this. Now, Apple demoed this some years ago, but I'm still seeing folks who don't use it, which is a real shame. Here you can see it's broken at the exact line that caused a problem. And what you can do is you can go up to the breakpoint and click on Object-C exception throw in your call stack. Tell me where it actually threw in the Object-C runtime. You'll see a load of gibberish, because it's all assembly code. But then what you can do is you can go down to the bottom right corner and look for the LLDB prompt, go into there, and then run PO$arg1. And it will tell you the actual mistake that happened, the actual tiny slice of the error you really care about. And then, of course, all sensible people will say, okay, if I can do PO$arg1 there, then I can go back to the breakpoint navigator in the top left corner, find my exception breakpoint there, and add that as an action to the exception breakpoint. So it automatically runs that as soon as an error is hit. This should be a default thing for everyone. In fact, it's so useful, I really recommend folks put that everywhere in their programs, which is trivial to do in Xcode. You can select the breakpoint you want, you can right-click on it, and then move it from the current project to all your projects, your user area. You can even share that with your team as a shared breakpoint that goes into source control. Everyone gets this as standard for your projects. It's a good idea. There are also symbolic breakpoints, which lets you add breakpoints to code you don't own. So this will, of course, break whenever a view controller is freed. And another apology, Cedric Luthi combines that with the sound debugging we saw earlier, so you can hear leaks. If you dismiss a view controller and you don't hear a pop sound, you've got a leak. And finally, there's one you might find useful. It's a Swift error breakpoint. This will break when any Swift error is thrown. I did a lot of work in Vapor 3 recently, and they've got some fairly, a nice way of saying it, dense code. And often an error will be thrown somewhere, I'm not sure where. I put one of those and find it online of some random file and then report that rather than sort of the final propagation version, which is useless. So it'll find you the root of where errors came from. And next up are watch points. So watch points are the ideal counterpart to breakpoints. They're there to stop your app when a change happens, irrespective of where the change happened. Now, often you'll find things like, what's making this variable change? Let's find out. And you step over, and then you step over, and step over, and step over, and then some more times, and then some more times, and you realize at this point, this was not a good idea. So breakpoints are there to pause when a location is reached, or when an event happens. They're great at that. They leave them in place for a long time. But watch points, they pause when a value is changed by any part of your code. You care about the value changing, not the place it changes. And they're temporary things, they're ephemeral, really. For example, here, I have a variable, subscription loaded is false, and I run some methods, and by the end of it, it's changed its value, and I'm not sure who's changing it. I want to find out why. Well, you just select the variable, place a regular breakpoint, wait for it to be hit, select the variable you want to watch, go ahead and right-click on it and choose Watch the Variable. And now, continue your program. And Xcode will run the code normally, and when it changes, it will notify us. It was false, it's becoming true. And later on, it was true, it's becoming false. We can continue and let Xcode tell us when it changes. And when it stops there, you can go down to the bottom corner here And you'll see we are in subscriptionsloaded.setter, the setter for our property. You can click on that and see a little call stack of where it came from to get to there. If I choose download subscriptions, you'll see, hopefully, that's where the change happened. So, breakpoints and watch points. 2 of 4 done. You're getting through this. Layouts. These can be surprisingly frustrating to debug, right? Because you can't peek into auto layouts to figure out what's going on, which is probably a good thing for our brains. And as a result, it's common to see folks burn through so many hours without really knowing how Xcode can help them. By the way, I've been told if you take a picture of this and tweet it, Evo the organizer will buy me dinner. So on behalf of me and my hungry stomach, this is your chance to help me out, okay? So you also see people who compromise their design rather than try and debug more complex layouts, which is a real shame because Xcode's got some wonderful layout debugging tools. I'm going to walk through 6 ways Xcode can help you identify and resolve problematic layouts. Hopefully the first thing you know, the view debugger, then recursive descriptions, identifying constraints, exercising ambiguity, layout feedback loops, and pseudo languages. 6 things. There are more, but these are my 6 favorites. So number 1, the view debugger. I hope you're already using this. It pulls apart your views in 3D so you can see exactly what's causing problems. You can find hidden views more easily. I'm not going to explain it further than that, other than to say, not enough folks realize in the bottom left corner is this filter box. Because a view debugger shows you lots and lots of things. And this filter box is really, really clever. You can type any class name in there, any subclass or parent class name in there, any text string that appears in any control in there, and it'll show it. This is just finding any labels or buttons with the word intensity somewhere in there. Even better, when you find a view you care about, you can right-click and say, focus on just this view, and it'll get rid of everything else. All the things you don't care about that's confusing you will be hidden. You can look at just the bit you care about. Second, recursive descriptions. All UI views have a private method that prints out an ASCII form of Xcode's view debugger. Now, this is really easy to call from Objective-C. The nicest way I've found from calling it from Swift is this, PO view.value for key recursive description force unwrap. It's only private, straight from Xcode in the LLDB area. It's not a runtime thing. And this will print out a description of your thing in text. Now, this is different, of course, to the view debugger. The view debugger has lots of fancy effects. It has view controllers. It has all the auto layout constraints being shown. It has that nice filter box to find things quickly. So there are good reasons to use the view debugger. But LLDB's version, the recursive description ASCII text, of course, is plain text, which is much easier for a lot of us to read. It shows all the values by the same thing together on the same screen, rather than have to click through things. You can see them side by side. And of course, it's great for diffs. You can take the old thing, the new thing, and say, what's changed to make my layout broken? And it will tell you. Number 3, identifying your constraints. Here is a leading anchor constraint for a prompt view, makes its left edge match the left edge or leading edge of a parent view, and enables it. You should nearly always just add the extra line of code to give a meaningful identifier to say what this is. Make it human readable. If you do it in IB, fine, there's a field right there too to select your constraint and say, that's my identifier. And so the next time Xcode vomits its layout errors at you, you can say it's a prompt leading or the prompt trailing constraints that are causing the issue and find it quicker. If that doesn't work, of course, please use wtfauto-layout.com, why the failure auto layout. You just paste your errors in there and it will just render them nicely to you saying, here's what happened, try and fix it. It's actually written in Swift, Vapor. Number 4, identifying constraint ambiguity. So you should know by now that, of course, auto layout requires us to provide constraints that are valid and not ambiguous. That might mean providing leading, trailing, top and bottom constraints or leading top, width and height constraints. But what happens if you have height and width plus top, but nothing for the X? And that's not enough for auto layout. It does not have an X location for the view. The result is an ambiguous layout. As far as auto layout is concerned, you are speaking gibberish. And it manifests itself as views appearing in different places than you expected. I did not want that box to be there. And you can debug this easily because all UI views have a method, exercise ambiguity in layout, that helps. Different possible values are randomly selected each time it's called. So I put that in touch as began, and when I tap the screen now, it moves from there to there to there to there, and so on. It's randomly moving each time I press the screen. It even has ambiguous layout property you can read, return true or false, saying yes, it's ambiguous or not. But it also prints out more information. And it will tell you the problem constraint, the min x. I don't know where to put this in the x-axis. Number 5, layout loop feedback debugging. You've got view A, which contains subview B, which contains subview C. What happens if C changes the frame of A? Well, obviously, A lays out again. It'll think, okay, A does B, B does C. But if the loop happened the first time, it'll happen another time. So it'll go around again, and then again, and then again, and then again. And of course, this will kill your app. And worse, if you pause your code, you won't see any meaningful information there. You'll see loads of auto layout work happening inside Apple's APIs. It's not clear what's causing auto layout to choke. And that's where the layout feedback loop debugger comes in. It is one of Apple's lesser known tools. It's disabled by default. When it's enabled, it allows views to lay out themselves some number of times, x times, where you choose the value of x between 50 and 1,000. And when it hits that limit, it will allow it to run a few more layout times to collect some information, and then raise an exception. To enable it, you want to go to the product run menu, hold down the Alt key, Option key, to get run ... In there, you want to find the Arguments tab, and in there, enter UI view layout feedback loop debugging threshold 100. Totally guessable, right? And now give it your layout feedback loop. Or trigger one by hand, whatever works for you. You could do one by hand if you want to by just doing something like this. When you lay out subviews, just do it again. And for even a trivial layout, like one view, you will get over 500 lines of output, because it will tell you the complete call stack that it took to get to layout happening, why layout happened in the first place. It'll tell you exactly which views are laid out and in which order, so you can see which one triggered the relayout. And it will warn you if ambiguous layout was a part of the problem. Number 6, finally, Xcode pseudo-languages. If you've used auto layout to create designs for your app that you kind of like, it's kind of nice, you can stress test that by using launch settings. Again, back to the same run menu, hold down the Option key because you know Apple. Click that, and this time you want to go to the Options tab and look for the language for your app. It's set to system language by default, so whatever language you use naturally. Click on that, you'll see all languages supported by iOS. Then scroll all the way down and look for double-length pseudo-language at the very bottom almost. These are virtual languages that support debugging. And my app looked okay before. When it starts to double strings, you'll see the labels and buttons don't fit anymore. They're being clipped. There isn't enough space for them. I've used exact widths. And this is fantastic for any languages that have long words. And I think some of you are quite familiar with these languages that have very, very long words. I'm not going to shame myself by pronouncing that. So, that gets through layouts. Let's just briefly, on the home straight now, look at memory, the final topic, just brief. Again, not an instruments talk. Instruments are a great collection of tools for finding memory problems. We're doing just Xcode here. I hope you already know the debug memory graph tool. It makes nice charts like this very easily. It looks really cool in lunch and learns at your company. It does things like this too. It does reference cycles, finding them for you, which is awesome. But when you're faced with lots and lots of allocations, it can be hard to figure out where the problem started. And annoyingly, it doesn't tell you that by default. You've got to enable it. You've got to go back to that damn options menu again, this time go to diagnostics, and enable the option malloc stack. Now, I've chosen just live allocations only here, which is a performance optimization. It just tracks the bits you really, really need. It'll track when and where things were allocated. While you're there, I recommend you actually enable another option called malloc scribble. It's just above the malloc stack option, and every time you free your memory, it'll be written over with 0x55. So there's no accidental storage of data. It's a really good idea to have them both enabled, and it actually helps the debug memory graph work better. And now we go back to your little cycle. You'll see on the right-hand side a call stack where your code is in black, Apple's code is in gray. You can see exactly what caused the loop to go around. So that is memory. So, to summarize, basics. Crashing your app's awesome. No. Print is fine for basic work, but there are better alternatives, right? You should use assert. Everyone should use assert and precondition. Swift does. If they think it's right, you should do. And of course, fatal error makes your code clearer because you can say, this should not be the case. You know, if you can't find a table view cell, it's gone really wrong. P, PO, EXPR, and frame variable are all different, have different purposes. Learn them all and use them all. They're all awesome. As for breakpoints, I hope from today on you will stop adding and deleting the same breakpoints again and again and again. Add them all once, use conditions. Please play sounds to find errors from networking and things you can't see. I heard Caroline Nitz talk about using that for drawing. If she thinks of views drawing infrequently, she doesn't realize, she'll play a sound when the view draws to try and debug that. Please use exception breakpoints, and I guarantee you watch points will save you time. They're absolutely incredible, particularly for very large code bases. For layouts, you are not alone. No one likes doing layout debugging. Please filter the view debugger. It's really powerful. It's really pretty. It makes for great dub-dub presentations, but it's a wealth of information. It's hard to dig through without the filter. Always use constraint identifiers. There's no reason not to. You can exercise ambiguity. It's a bit of a blunt tool, but it works to find out where the confusion is. And make it Xcode's job to figure out why your layouts are looping, not your job. It will do it for you. And finally, memory. It is best done in instruments, but Xcode can help. If it's going to help, why say no? Basic graphs, awesome, but if you enable malloc stack and malloc scribble, it'll work harder. Well done. You've saved it through the debugging talk. It's been a very intense talk. I think it's quite long for a 50 minutes talk. You've stuck through it. Well done. I should say, if you are not bored of debugging, Phil Nash has even more debugging in this room after the coffee break. He's promised me it's complimentary to this talk, but I bet he's lying. Any questions? Find me on Twitter. I am 2straws. Thank you very much.
We also still have time for some questions now. Anybody?
Okay, so my question is, do you have any tips or for maybe a reason why LLDB can be very, very slow?
Okay, so to be fair, Apple have addressed this publicly on Twitter because people like me whinge a lot because I'm sure you have the same problem. You try it out, it doesn't work, and you go P, some variable you can see, some variable I can see, and LLDB's like, can't see a thing, mate, can't help you, you're on your own there. And Joe Groff from the Swift team has said, it's not really their fault. We keep changing our internals so often at this point that they can't do anything about that. So the LLDB team are doing their best. There's people like Kate Stone at LLDB are doing great work. But because Swift evolves so quickly, it's simply nothing you can do. So LLDB at this point, and sadly for the last 3 or so years, has been quite flaky on Swift, and really it's hit and miss. So honestly, the best thing you can do is roll some dice, hope for a 7, and that's as lucky as you'll get, quite frankly. There's no magic to making LLDB work.
Yep, hello. I have a question. Probably it's kind of a ridiculous question, but still.
My favorite.
How would you debug like Realm stuff? I mean the Realm library. How would you debug the multi-threading issues while using the Realm?
Realm?
Realm, yeah.
Realm.
Yeah, Realm database. I mean, how to debug this shit? You know?
Oh, come on, give me an easy, non-controversial question, please. The nice thing about Realm versus core data is that they're very approachable people. Whereas, I mean, don't get me wrong, I love the core data team, they work very hard, they're doing great stuff every year, but it's very, very hard to get answers from them, and it's pretty much impossible to get fixes from them. Whereas the Realm team will talk to you on Twitter. So your best option nearly always is get friendly with the people directly, get to know them, hang out with them on Twitter or whatever, follow them or chat to them, whatever, and then they'll be like, yeah, fine, here's a solution, here's a workaround, here's a fix. That's the easiest thing to do, is actually what Ash said is soft skills, just talk to them, face-to-face or on Twitter.
Yeah, I mean, you should probably make an extended version of this debugging like a pro to multi-threading debugging.
Oh, that would take several days, man.
Yeah, thank you.
Okay, thank you very much.